Today we'll take our 3D printed submarine to a flooded uranium mine and try to get to the very bottom at 243 meters deep. So this is the drone which will get us there. Previously we've only taken it to about 8 meters underwater at max, but now the water pressure which it will need to withstand is massive. Now look, this red 3D printed shell isn't waterproof at all, it's the acrylic pipe inside which holds all of the electronics watertight. At this depth, the force exerted at each end of this pipe is over 1 metric ton. It's equivalent to a Toyota Corolla sitting on this tiny surface, or alternatively a world record holding pumpkin. Anyway, it's a lot. The maximum pressure we've tested these Endcaps to in our pressure chamber is equivalent to 85 meters, which is alright, but the mine is still about 3 times deeper. We have 158 meters to go, so yeah, it's time to upgrade this pipe, or rather the Endcaps on each of its ends. The second necessary upgrade is the Tether, which we'll use for communication with the drone. So far we used a 100 meter Ethernet cable and I would like to extend it to 300 meters. Let's do the Tether first, because I think it's the easier task. So, a standard Ethernet works up to 100 meters. Instead, I'll use fiber optic, because it literally has 400 times more range. It works by sending information as light signals through thin fiber strands. Because of that, it's also way thinner than Ethernet, which is great for us and underwater drones in general. There are some downsides though. The manufacturer of this cable says that basically you shouldn't bend it so that the radius of that bend is less than 35 millimeters. Otherwise it might lead to temporary signal loss or even permanently breaking the fibers inside. This can be an actual issue for us if the cable tangles on anything underwater. Despite that, I decided to ignore this issue and bought a sample to test maybe if they're not just lying. I have a feeling like it's more durable than they claim.
Piotrek, uwaga, patrz na to.
This is the distance we're measuring in the top left corner. If a cable stops working, Gandalf will stop nodding on this screen.
2.5 and they said 35 millimeters. So that's 25 and it works. This is 20, works. That's 10. It's literally 10.
Why are you doing that, sir? I hate this.
I need this. I need to find out. Okay, that's 0.
Okay.
Oh!
Gone. What?
No.
Ah.
If I press here.
No, nie, już nie. Czekaj, zobacz się. Okay. It's recovered. It's
Okay,
very
this.
interesting in this.
Yeah, this is
Okay,
quite nice.
fiber optic is superior.
Yeah, fiber optic is way superior than Ethernet.
Although it's probably much less resistant to cooling.
Oh, let's test the resistance to cooling. Oh no.
Okay, oh wow. I can actually kill myself from this fiber optic.
Like hang yourself?
Yes.
We've only managed to destroy the cable after a violent rubbing against a pair of scissors.
Oh, okay, now it's broke.
Seems like we're set with the cable itself. Now, there's another big challenge. You can communicate with the Raspberry Pi inside of our drone using Ethernet, and normally we're just connecting the same Ethernet cable to the computer on the other end of the tether. But there isn't just like a fiber optic connector on the Raspberry Pi. That's why we'll need to use Ethernet to fiber optic converters. I found these ones on AliExpress and I like them because they are small enough that they can just fit outside of the drone on the tether itself. This way we won't have to modify the electronics inside the drone. On the other end of the tether you have another converter, and that way you can just use it as a normal Ethernet cable. Here they are. These two boards will triple the range of our drone. Here you plug in the fiber optic and here the Ethernet plus power. After initial testing, it works. Since one of them will be underwater, I decided to cover the entire board in epoxy resin. Not a pretty solution, but well, it works. The downside is that if I mess this up, I could lose the entire tether. Let's print a container for the epoxy. So I made a slight mistake with the epoxy. It leaked through this cable to the connector, which made the cable very stiff, and after moving it around, the wires inside just snapped. Fortunately, after a quick depression and 72 hours, I finally figured out what happened, got rid of the hardened epoxy and soldered a longer cable. Now it's ready. There's one more thing left to do with this tether though. Imagine all of this tangling up when we're in the mine. That would be a nightmare.
Yeah, that's horrible.
That's why I'd like to put it onto this garden hose spool. The tether connects to a Wi-Fi router inside here, which connects wirelessly to the computer. Let's wind the tether onto it.
It took an hour and 3 minutes to get this cable onto this spool.
It's a long cable, and despite that, its size is comparable to an Ethernet cable, which is 10 times shorter. At the end, I also thought to 3D print this mounting system to attach firmly to the drone and also add some buoyancy foam. Now it finally works with the drone. Turns out the tether wasn't that easy after all, but now let's do the end caps, and let's focus on how we're going to upgrade them so that they withstand 243 meter depth. First of all, they are 3D printed, but also we filled them with epoxy resin. We designed them in a way that the cables can go through from the inside to the outside. There are 2 pipes in the drone, one for the electronics and one for the camera. That makes 4 end caps altogether. Now the only model redesign I'll need to do is to thicken this end cap, which you see broken here. I would have done a deeper investigation on what are our current design flaws, like for example I worry about these small end caps for the camera, but the tether took quite a bit of time already. We'll test the upgraded end caps before the mine anyway. That's the cross section of this end cap before, and that's how it looks like now. That should be it. That's a future video. Now, printing time. Printing time. Now, let's prepare all of the cables for these end caps. Okay, now comes the epoxy part. A thing that was suggested and tested by one of you who built our drone is to use a vacuum chamber to pump out all of the air bubbles after pouring in the epoxy. That improves the strength and random imperfections in the pour. Here's the vacuum chamber. So after pouring in the epoxy, I placed the end caps inside, and here it is. Quite a lot of bubbles. Right here is where I made another mistake with the epoxy.
Oh shit.
I released the air pressure too fast, and the air coming from the outside hit the liquid, which spilled it all over the place. Thankfully, I was able to clean this up and nothing really was lost, but I remember to not do it next time. In order to harden the epoxy faster, I put these in our special 60 degrees Celsius oven for a few hours. After a few hours, Now one more epoxying process and we're ready. Let's go to test these end caps in the biggest pressure chamber in town. As you can see, it goes to 160 bar on the manometer. That's about 1 mile underwater. But I'm sure we won't need that much pressure to break it. By the way, this pressure chamber itself is quite old.
Jak stare to jest urządzenie?
Ojej,
20 lat?
nie, może nawet więcej.
W 100% wodą napełnione jest.
Tak.
So let's begin pressurizing. We'll stop at 200 meters at first.
Czyli na 200 chcielibyśmy zatrzymać.
If the end caps break, we'd see a pressure drop on the manometer.
I już stop.
Ha! Mamy 200. No ile bo tam?
To dobrze.
Z 10 minut można poczekać, nie?
To już jestem zadowolony.
After 10 minutes, we continued increasing the pressure.
Do drona o 250 to było chyba?
No, Philip, it was 300, not 250. I will realize that later. Anyway, this test was a huge success. After retrieving the end caps, we could actually see what happened to this thing at 30 bars. You can see that the O-ring pushed this part up a bit. Here, the top part detached from the bottom part, leaving this hole. Perhaps the plastic could be thicker right here. Right, now let's make them once again for the drone. These will swim in the mine. And let's put them in the drone. And we are finally ready. Now I'll go charge everything and tomorrow we take off to the mine.
Alright, so right here, right now, we are almost ready. The only thing left is to pack everything. The red drone, the green drone, computers, the spool, charger, controllers. Right here, right now, right here, right now, right here. I have it.
Ideal.
In the middle of the road trip, we got an email. So, we just got accepted for Open Source, which is an event, kinda like Maker Faire. Let me finish my train of thought here. We got accepted to exhibit with our underwater drones at Open Source, which is organized by William Osman, and all of these people will be there too. So on 15th and 16th of July you can meet us there in San Francisco and actually try to pilot our drones if you haven't built them yourself already. So see you there! Let's get back on track. We have everything in 2 backpacks, plus the spool and plus the tripod.
Plus your ego.
And
Philip, I'm not sure if your ego will fit into the mine.
now let me introduce our guide.
Martin, the mine guide.
He gave us these helmets, explained a lot about how this mine works, showed us some uranium, and was a really great guy. Here's where we entered the mine. By the way, it's called Kopalnia Podgórze for anyone interested. First, we wanted to take a slightly dangerous route to the less explored mineshaft. The path went through some tight tunnels and over this 25-meter drop. We opted out of this one and went to the safer option. Then we finally arrived.
Wow.
dobra, to jest niezły challenge. Kurczę. Alright, so we can now set it up.
Yes.
Let's go.
This is DIY engineering in the mine. So now the drone is attached permanently to the spool and to the 300-meter tether. Maybe this.
Use the exactor knife. Really, that's the appropriate tool, Philip.
Yes.
Alright.
Now we can turn on the spool
Yes.
here. 88%.
Good.
Oh,
Yay!
yes.
Alright.
Here's the Wi-Fi. Seems to be working.
Okay, so can we put it in the water and can
Yes.
you record this?
Finally, we can begin the journey down the mineshaft. Whoa. Martin told us that the right side of the shaft should be unobstructed to the very bottom, but it's unclear because the deepest diver got 276 meters in 2018. After 30 meters there's a perpendicular corridor and then there are more each 40 meters down.
Alright, when do I need to switch to FPV?
You can go.
Okay.
While we go down, you'll see the depth in the bottom left corner. The orientation of the drone is here and the rest of the information here. Peter is swimming at 50% speed, just to be more precise.
I have no idea how it's oriented. I have a very little...
Tak, jesteś zorientowany, teraz jesteś tak bokiem.
Teraz rozumiem, no.
Dobra. Also, while we dive deeper, I want to tell you how you can build this drone yourself.
Na jakiej głębokości jesteś?
9 metrów.
Over the past years, we've built an extensive DIY course, which now teaches over 200 students how to make this thing from scratch.
Piece of cake.
Can you turn off the lights? Okay. No. A lot of them are actually finishing these drones and using them for their own needs.
20 metrów.
Like these drones built by David, Taras or John.
Oho.
And recently we've even opened a private community forum within the course, where you can exchange ideas and help each other out.
No tu coś jest, zdecydowanie. 28 metrów jest wejście gdzieś, no.
So after watching this video, go to cpsdrone.com and sign up for a free training, where we'll show you everything you need to know to get started with building the CPS-5 underwater drone yourself. Link in the description.
Dobra, jestem na 30 metrach i widzę rzeczywiście ten poziom. Poziom? Tak.
Right here is where unfortunately this camera with the audio turned off, so now I'll subtitle the GoPro audio. We continued past the first corridor, as it wasn't that easy to turn around and see clearly what's inside. Now, there was a lot of particles in the water, for example these bacteria. We realized that the video really suffers because of how much light is reflected off of these particles. If the lights were further apart from the camera, then the image would have been much clearer. You can see that on this footage we got in the mine. Now the flashlight is close and now further away. We'll keep that in mind with future designs. Meanwhile, I couldn't see any lights from the surface at all at this point. Peter piloted the drone at a very slight angle so that he could steer left and right just by rolling the drone over to that side. He also asked a good question. We quickly got to the second corridor at 70 meters.
Now, Philip, how confident are you in your 300-meter Endcaps?
I mean, I'm actually quite confident because of my test I did, that at any time the drone might just disappear. Yes.
And now we've just surpassed the maximum pressure we could get in our DIY pressure chamber at 85 meters.
Quite a lot of meters. Okay, so we say that CPS5 is waterproof to 85 meters underwater. Now we're at 100. Yes, so actually we beat that. Oh! Alright, it's still going. Is it? Yes.
And now we've reached the third corridor. Just under the third corridor we encountered this obstacle, but thankfully for now it was easy to avoid.
11.5 birds. That's very frightful. Yeah, we're swimming quite slow. Yeah. So it will last for a good minute. Oh. Alright. That's scary.
At this point the tether was under a lot of tension. Martin suggested that I should stand there to prevent the cable from rubbing against the wooden beam.
Like the weight of the cable is actually pulling it down. Oh shit! Thank you. Can you go deeper? No. It goes deeper. It sinks right now.
We needed to pull out the drone immediately.
Widziałem, jak ciśnienie rozwaliło kamerę, bo się nagle pojawiło bardzo dużo kondensacji. Stop.
The tether clearly caught on something, so Martin hopped to the other side of the shaft to pull it at a different angle.
Yeah. Okay.
We weren't sure if it's possible to retrieve the drone, but after it steadily went up, we became more confident, and after a few minutes...
7.
Yeah.
Alright, yeah. Just a second, sir.
Heck. We can also try the maximum depth with the other drone.
No, that's not a bad idea. I really want to keep the other one. Bravo. Dzięki.
So then, what exactly happened? Well, the endcaps in the camera pipe have failed, causing the water to instantly leak and destroy the camera in the drone.
It was still pressurized.
In fact, the entire top part of this endcap separated from the bottom part. In the pressure chamber, the same kind of endcap didn't fail until 300 meters, so for large depths we should definitely come up with a more repeatable design. With 130 meters reached, this adventure was still a really big success. We'll definitely come back here with an improved drone. Let us know where else in the world we should take it. Remember to go to cpsdrone.com and get your free training, in which we'll not only explain how the CPS5 works, but also how you can build it yourself. You'll also get access to the entire bill of materials, so everything you need to get started. Link in the description.